on the test. That was my mistake, okay? And it was in one of these problems here. So, but there was so if you did okay on the explanation, I gave you the credit. But there was something that I'm trying to use the functionality of the test program, and so I can get multiple versions of a problem. And one of the things, it produced an E, and it didn't mean the E. That's 2.718. It meant just it was a variable. So that popped up in the second part of a problem that was like this. I did publish these problems. I'm not going to go slow and just give you time to write them down. So if you want you can write as we're going, and then you can go back and grab the problems later. That's fine. So we're supposed to talk about whether the function is continuous or not. And the first part of this question actually asked you to find the limit of the function. So I'm going to do that first, because that really is step one to figuring out if it's continuous. Okay. I will, Tina, at the end. Remind me again at the end if we've got time. Okay. All right, so I'm going to start by taking the right and the left-hand limit. And a lot of you understood to do this, but your notation was atrocious, okay? You have to write it the same way I'm writing it right now, okay? So please take note of this. Remember, you are technically allowed to use notes on the test. However, I have a feeling that some of us are using notes too much and running out of time on the test. So you have to make sure you understand what's going on. You should still, just like as if we were in class, just like it was last year, you practice the study guide a couple times, or you practice the practice problems I put out there. And I know I didn't put a lot out there for this, okay? I'm trying to wean you off of that. But practice this practice test again, okay? Or this test again. Practice these problems that we're doing right now again, okay? All right, so the left-hand side is the one on the top because it's less than. And then we're also going to find the limit as x is approaching -1 from the right side, which means I'm plugging into the top branch and then the bottom branch. All right, so I'm going to go ahead and just plug in. I'm hoping that they come out to be the same number. So I'm going to plug in 2 to the negative, and then I'm going to put a -1, which the double negative is going to go positive, and I get 2 to the first, which is just 2. Okay. All right, I'm going to plug in a -1 into this. So I get -1 plus 3, which is 2. So the good news is that the limit is equal to 2. You need to state that. Okay, so we're going to say, therefore, the limit as x approaches -1 of f of x is equal to 2. So this would have satisfied the first question. You need to have each one of those steps very clear for me to be able to read, okay? I am not going to give you a question on the test where the limits do not come out to be the same number. I can't tell you how many mistakes I saw where you wrote something down wrong. You copied it wrong, and then you got the answer wrong because you did not get these limits to match. Please double and triple check. If your limits aren't matching, you need to triple check that problem, okay? All right, from here, now let's deal with the continuity. There's 3 things we need to know if it's continuous. We have to know that the limit exists, okay? We need to know that the limit, that the f of whatever the value is, so what f of the number exists, okay? And then we need to know that the limit equals the f of whatever the number is or whatever the value is, okay? So you're going to make me some statements, okay? So for the continuity, we would say the limit, even if you just showed the calculation, the limit as x approaches -1 of f of x equals 2. That proves existence, okay? The limit, or the f of, and then you're going to tell me what the value of the function is. So we're supposed to be going to -1. -1 is equal to, in the bottom one, show me this calculation again. So I actually want to see the calculation this time. There were a few people who had some interesting, unique answers. I gave some credit, but I'd rather see these calculations. This is what the AP exam is going to look for. Okay, so you've now proven to me the limit exists. F of -1 exists, and now you need to make the statement, therefore, f of x is continuous. Oh, no, not yet. That's not what I wanted. I'm going to make this third statement, and then I'll say it's continuous, okay? And then you're going to say the limit as x approaches -1 of f of x equals f of -1. Then say, therefore, f of x is continuous at x equals -1. All right, I hope we're doing a little bit better on that one. And hopefully we're very clear about the steps. So here's what I want you to do. I want you to have time to wrap your head around that. So I'm going to give you a second one to do. Okay, I'm going to be quiet for 2 minutes. So I want you to take 2 minutes, try to get the left, get the right, get the overall. Practice writing out the steps for continuity. I'm going to shut the door because the noisy child is out there. I give you about 30 seconds. I'm going to ask you to help me out in the chat here. Okay, tell me in the chat, what'd you get for the limit as x approaches 2? Good, 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 good. Thank you for letting me know you're paying attention. I really appreciate that. It's hard to talk to a screen all day of dots. So x minus 2 squared. So you're telling me 2 squared is 4, 8 minus 4 is 4, like it. 6 minus 2 is 4. Perfect. And then you wrote the notation for me. The limit as x approaches 2 over all of the function equals 4. Okay. All right. Now I want to, we got to talk about continuity, right? So I've kind of already stated my limit, but technically it's going to be in a second problem, right? Because the way I wrote the problem on the test. So, hey, my limit exists. Then I have to evaluate f of 2 equals, and I got to figure out it's going to go into the bottom branch again because there's where my equals to is. And I'm actually going to write, even though it's redundant, I'm going to write my calculation again. Then I'm going to say the limit as x approaches 2 of f of x equals f of 2. Therefore, f of x is continuous. That's what I need to see exactly on the test. Okay. I've been told, and I don't see mine anymore, that the little nod app is gone, so I'm sorry, but I hope we're understanding. Do we understand how to do the continuity problem? Give me a smiley face in the chat if you understand how to do the continuity problem now. Because I don't want to see you get that one wrong, okay? It's not hard. It's just a lot of steps, okay? Thank you for the smiley faces. It makes me feel good. All right, awesome. Smiley faces are better than thumbs up anyways. We had it separated into 2 questions, Marilyn, okay? And so it was worth like 50 each, so it was like a 100-point question. Would you still put an x equals 4 at the end? That would probably be a good idea. So at x equals 4. And you guys, I write that symbol a lot. I really shouldn't. Really, on the AP test, we don't want to see abbreviations. We need to see that word at. Okay, but that was a really good question. Thank you, Noelle, for asking. Okay. All right. Our next thing that we're going to talk about is vertical asymptotes. Okay, so I had a kind of a really cryptic question. Apparently, I shouldn't have done it that way. I was trying to be creative in the way I was asking the questions on the test, and I should have been a little less creative. So the first thing we're going to do is we're going to have to do a little bit of factoring here when we talk about finding vertical asymptotes. So because we're trying to look for something to cancel, we know when it cancels, it's a whole, and when it's whatever's left behind in the denominator is a vertical asymptote. Of course, I picked on one that has lead coefficients. I probably shouldn't have done that, but we're going to go for it. So I got to get out my good old magic X. So two numbers that multiply to -24 and add to 5. Oh, let's see. I think 8 and 3. The 3's got to be negative. If you were in my class, you know about the box. We're learning this just now in trig right now. So 8x minus 3x. Let's see. Two numbers that multiply to 3 would be 3 and 1. My 3 is going to have to go on the top. I'm going really fast because you should know how to do this. 1 divides 8x 8 times. 3 divides -3 -1 time. I check. -1 times 8 is -8. Did anybody factor the denominator yet? What'd you get if you factor the denominator already? I'm going to start. If you've got it, tell me. 16 and -10. Let's see. 8 and 2, both negative. Has a lead coefficient, still need the box. Top left-hand corner is 2x squared. Bottom right's got to be that 8. And then two numbers that from the magic X followed by an X. I know that 2 is 2 times 2. Ooh, no, sorry, 2 times 1. I don't really know how that goes because we had oh, you know what? There's a greatest common factor I missed pulling out, wasn't there? All right, well, we'll have to pull it out of one of these. I'm going to put the 2 here. So I know that that has to be -8. And then this one I divide into there is -1. And then so that checks out. But look at what happened. I got 2x minus 8 times x minus 1. And I should really have pulled a 2 out of this. I'm going to pull it out as I put it here. So 2x minus 4 times x minus 1. All right. I am going to cancel. Okay, help me out in the chat. When it cancels, what do we have? What is that called? That's a whole. Good job. What I am really after is what is left behind in the denominator. So what's left behind, that's my vertical asymptote. So I'm going to set that equal only the thing that had the x, though, not the 2. So I'm only going to set the x minus 4 equal to 0, so I know my vertical asymptote is at 4. Okay. All right, we're going to try another one together. Do I have more than one of these? Yeah, okay. So let's try this one together, and then I'll give this one's a little bit easier and quicker, and then I'm going to give you one that's kind of in between on your own. Okay. All right, so vertical asymptote, I'm going to have to factor. Anybody know what kind of factoring I got to do in that numerator there? Tell me in the chat. What do we call it? Who remembers? What do we call that factoring in the numerator? Okay, Erica's saying difference of squares. So that means I've got to take the square root of the front, which is x. Fallon's got it too. Good job. Take the square root of the back, which is 4. Make 1 a plus and 1 a minus. All right. What do I have to do to factor the denominator? Tell me in the chat, quick. We're going to take out a 3, greatest common factor. Awesome. When I take out a 3, I get x minus 4. All right. So I look like I am canceling this. So we get x plus 4 over 3. Do I have a vertical asymptote this time? Yes or no? Tell me in the chat. In this case, there isn't a vertical asymptote. Very good. So this one is no vertical asymptote. Good thing we did that one together, huh? Okay. All right. So Noelle is asking why. There is no variable left in the denominator. So there's no variable in denominator because we take whatever's left behind in the denominator and set it equal to 0. It doesn't make sense. I'm getting my Christmas tree stuff all over. It doesn't make sense to set 3 equal to 0. There is no way to solve that. okay? All right, I'm going to give you one. I want you all to try it. So, little bit of GCF-ish, maybe some difference of squares, maybe some magic X. I'm going to give you a minute. Try to find the vertical asymptote bonus points if you can figure out if there's any holes. Okay, so I'm going to give you 2 minutes. Don't type anything in the chat till I say. Okay, tell me in the chat what's the vertical asymptote and bonus points if you got the hole, if there was a hole. Okay, tell me right now what you got. I'm going to start factoring. Will you do that? Okay, let's see where we're at. I don't see everybody yet. Okay, but I do have a hole at x equals 8. I'm seeing that. Hopefully you caught. I went really fast and did my work, right? I factored. And then the vertical asymptote was what was left behind at x equals 9. I see a few of you just typed 9, okay? So what I need you to be aware of and make sure you're doing is that you're saying that it's x equals. It's not just the number, okay? So I don't know if you had that on your paper or what, but make sure you're saying that it's an x equals, because technically an asymptote is a vertical line, and we write a vertical line as x equals, okay? And part of today is, I'm sorry I didn't make a fancy pear deck. I just didn't have time. So I really need you guys to be using the chat. Right or wrong, we're not making any judgments today. We're just trying to make sure everybody knows what they're doing to retake this test, because we all need to up our test scores, okay? I mean, again, when we do a retake, number one, you need to show up, okay? Nobody got 100%, so I'm not doing any enrichment of any sort on this one, or or extension activity on this one, because we all need to get our scores better. So we are going to make sure that that happens here, okay? So we are now going to talk about horizontal asymptotes. We are technically supposed to show our limits. We could have done this really in like an Algebra 2 class without showing our limits, but there were 3 things we need to remember when we're talking about a horizontal asymptote, okay? If our exponent on the top is bigger, okay, so I have the top bigger, so meaning like I have like an x cubed over an x. When I put infinity in, it will grow on the top faster than it will grow on the bottom. So that means that my horizontal asymptote would be equal to infinity, which means that there is none. Okay. If my exponent on the bottom is bigger, okay, so I have something like x over x cubed. that means that really this would cancel to this. And the bottom, when I put infinity in, would grow faster than the top, meaning it's going to be a really small number. It's going to get closer and closer and closer to 0. So you would say, and actually this would be y equals, because we're talking horizontal, okay? So there would be y equals 0. If your exponents are equal, okay, it's the coefficients in front of largest exponent. Okay, and you're looking for your biggest exponent to be equal. Okay, we're going to try a few. So what do we notice about our biggest exponent on this one? Is the top bigger, is the bottom bigger, or are they equal? Tell me in the chat. Okay, and as I'm asking you to put things in the chat, these are questions that you all should be processing. You should be using kind of that self-talk to yourself. Hey, I need to go through this list of questions, just like Mrs. Ballard did, to make sure that I know I'm getting this question right. So they are in fact equal. Technically, to find a horizontal asymptote, we're supposed to take the limit as x approaches infinity. That's why it's saying show you your limits. So really I'm doing this. If I was going to plug infinity in here, okay, I know that anything other than the biggest exponent is going to be irrelevant, okay, because it's going to be huge. So I know that when I put it, I'm going to just look at the coefficients in front of here. I know there's a 1 in front of that. So my coefficients in front, ooh, that's not what I meant to do. My coefficients in front would just be 2 over 1 or 2. So my horizontal asymptote would be at y equals 2. And remember, a horizontal line is always y equals. All right, let's look at another one. I think I've got two. Yeah, I've got a bunch of these. Okay, so let's look at this one. F of x equals x over x squared minus 1. Okay, so I want you to look at the exponents. Is the top bigger, the bottom bigger, or are they equal? So tell me top, bottom, or equal. Good job. So the bottom is bigger, okay? So that means the bottom is going to grow faster. So here's how I think about this one. This is a terrible way to do it, but this is how I think about it. I ignore everything that's not the original coefficient. I know if I'm just looking at that, it really reduces to this, right? So if I was going to find the limit of this, and I was going to put an infinity into it, I've got a little tiny number divided by a giant number, which is going to equal 0. Officially, we should really write the limit as x approaches infinity of x over x squared minus 1 equals 0. Okay, so my horizontal asymptote would be y equals 0. Okay, bet you can't guess what I'm going to do with the next one. Let's see. Ooh, interesting. Okay, so now I've got a square root introduced. Remember that when I'm talking about putting in an infinity, right? Limit as x approaches infinity of the square root of x to the 4th minus 1 over x cubed minus 1, meaning these are insignificant. Okay, when I talk infinity, those are insignificant. So I'm really looking at the square root of x to the 4th over x cubed, which I really should not be writing an equal sign in there. Okay, it isn't equal. Which means I am looking at, if I take the square root of that, I've really got x squared over 3. So listen to my question this time. If this is what it reduces to, what is my horizontal asymptote? Do not forget the x equals or the y equals. Put it in the chat for me. What is my horizontal asymptote this time? Okay, good job. So we know that y has to be equal to 0 because my denominator exponent was bigger than my numerator exponent. Okay, are we going to do better on this test, I hope? Okay, than what I saw the last time? All right. So here's what, okay, I don't want to get, I want you to be able to think about this one right now. Okay. So given that we know we have to go to infinity, tell me in the chat, is the top one bigger, the bottom one bigger, or are they technically equal? Tell me in the chat what you think. Be careful on this. Okay, so we know that they have to be equal. I love the fact that Erica put technically they are equal. Okay, because remember, when we're going to infinity, we're going to ignore everything except for the highest exponent. Even though these guys kind of match right now, but we have that square root that's trying to trick us. And if I remember right, I put one in there with a square root because I did that on purpose because I wanted you to see this. College Board's going to love stuff like that. So really, this is like saying 2x over the square root of x squared, which would be 2x over x. And at this point, I use the coefficient in between, so my horizontal asymptote should be y equals 2, and I totally didn't even use my limits, did I? I should have, but I didn't. Okay? All right. Can you give, if this is making more sense now, can you give me a smiley face in the chat, please? Okay. Thank you for the smiley faces in the chat. I'm glad that that's going better. Okay? All right. Let's look at the limit as x approaches infinity. So this is no different than the horizontal asymptotes, you guys. It's the same thing. Okay? So what do you notice about your exponents in this one? Are they the same? Is the top bigger or is the bottom bigger? They are the same. Okay, so right now, in the chat, this isn't an x equals or a y equals because we're actually trying to find the limit right now. Tell me what the limit of this is in the chat. It acts just like the horizontal asymptote. So what's the limit of this? There we go. Good job. Okay, so just like the horizontal asymptote, these are insignificant. We're just going to look at our coefficients in front, which would be 2/4, which should be 1/2. Okay? And again, on these, we don't need the x equals or y equals because it was a limit problem, not a horizontal asymptote. Okay? But again, safe space. We can make this is the time to make mistakes and get them corrected. All right. So looking at this one right here, okay, it is approaching negative infinity instead of positive. I'm going to look at my exponents again. So which one's bigger, or what do we notice? Is the top bigger? Is the bottom bigger, or are they equal? Tell me in the chat. Okay, the bottom is bigger. So in the chat, tell me what does that mean the limit of this thing is? If the bottom is bigger. Again, it works just like the horizontal asymptotes. All right, nice job, everybody. It equals 0. So again, if it's infinity, little numbers are insignificant, right? Even if the little number was 1,000, it's insignificant compared to infinity. I would know that it's like 2x over 6x to the 12th, which I know that gets smaller. I know that this has to be a little tiny number over a giant number, so I know that that's going to be 0. Okay? Okay, looking at this one here. So what do we notice? Look at the exponents. Is the top number bigger, the bottom number bigger, or are they equal? Good job. The top number is bigger. Okay, so if the top number is bigger, what does that mean my limit is going to be? Jesus has a little lazy mathematician in them. That's good. Okay, I would do that too. All right, it is going to be infinity. You do not need to worry about spelling in here. Again, this is a safe zone. Okay, so we noticed that the top was bigger, meaning I'm not even worried about the coefficients in front. I've got something like x to the 4th over x cubed, which would really just reduce to x. When I plug an infinity into that, I get an infinity. Okay, so definitely equals infinity this time. Okay. All right, hopefully that's a little bit better. because I want you to do really well on the test. Oh, here comes another one. Okay, so everybody try that one on your own, okay? Don't put it in the chat yet. Try that one on your own. Okay, tell me in the chat what'd you get for your limit. You guys are making my day. This is awesome. All right, so I'm looking forward to grading this again. Okay, because I love grading, but I really am looking forward to grading this again. I don't know if you could hear the sarcasm in my voice. All right, so this is kind of like saying x over the square root of x squared. So we've got x over x, which would have to be the coefficients in front, which would just be 1. Okay, so very good job, everybody. All right, I think I've got one more thing. Yep. Okay, guaranteed this is there. I think I've got 2 of these to do, and then that's really it. We will have gone through everything. Okay, so we've got a function which find the value of the constant a, which makes the function continuous. Be sure to justify your solution using proper notation. In theory, for our function b to be continuous, I'm looking at Marilyn's question. When we are solving, the limit is not y equals. Correct, Marilyn. You don't put y equals when it's a limit, only if it says horizontal asymptote. Okay? All right. So on this one here, back to this problem. Technically, what we need to do is if it's continuous, we know that the right and the left-hand limits are equal. So I would write the limit as x is approaching, and I use this number, 2 from the left of 9 minus x squared equals the limit as x approaches 2 from the right of ax. I'm now going to plug in my 2's, okay, into the x's. So 9 minus 2 squared equals a times 2. 2 squared is 4, and then we get equals 2a. 9 minus 4 is 5, and then I'm going to divide by the 2. So the a value that would make these two that piecewise function continuous is 5/2. Okay. All right, I'm going to give you one. I want you to, that's just like that one. I want you to try it on your own. Okay, so everybody try that one. See if you can figure out the value you'd have to put in. Remember, you need to take the right and the left-hand limit. Okay, let's see where we're at. Well, tell me in the chat really quick. What did you get for your a value? I'm curious. I'll go through the whole thing, but I want to see where we're at. Ooh. I'm seeing a lot of 6s. I'm seeing a couple of 2s. So it looks like we don't have agreement yet. Okay, so we're going to try it together. So I know I've got to do the right and the left-hand limit. So the limit, ooh, that's a weird L. Limit as x approaches 2 of x squared, 2 from the left. Ooh, look at this. Technically 2 from the right. Did you see how they swapped their equal signs? It wouldn't really super matter because we're going to plug it in anyways. And then a minus x. Okay, now I'm going to plug my 2 in to just the x. So I've got 2 squared equals a minus 2. 2 squared is 4. And then we've got a minus 2. I'm going to add the 2. So I've got 6 equals a. I think those of us that got 2, we subtracted the 2 instead of adding the 2. So always good to go back and double check our work. But thank you for being brave and putting your answer in there. Okay. All right. I don't know, what time do we get done at 40? Oh, we're down to like a minute. All right. So I need you guys to help me out. I'm going to put a poll out there. I kind of want to see where we're at with this lesson today. Okay. So I'm going to launch the poll. I want to know, and I'm not going to show this to anybody. I'm not going to show the results. I just want to know where you're at in your confidence on retesting on Monday. 1 is you're not confident. 5 is I'm going to get an A. Okay. 3 is I'm kind of in between. Maybe I'll study some more and I can do better on this. All right, it looks like we're heading towards like that 4 range. I've got a lot of 4s, which is really good. I'm hoping that today helped, okay? I know it's been a week or so since we've done some of that stuff, and we've got to redo it because we do need to get our test grades better. I know the bell just rang, but here's what you can't do, okay? You can't just study for the retest and not study for the new test, okay? I'm going to put that new test grade on the triad grade. You're not going to have a retest opportunity before the end of the triad because the test is on Thursday, triad ends Friday. You have to study for both. So please, before you come back to class on Tuesday, actually Wednesday for you guys, make sure you've done the progress checks, okay? Because I want to be able to answer questions, all right? Can you guys hopefully do that for me? All right. Okay. I know we had a question where today class is over, okay? So I will see you all. Have a great, safe weekend, okay? Give mom and dad a hug, okay? They need it. All right. So have a great Halloween. I will see you all on Monday for test. Yes, I'll put the horizontal asymptote page back up. And then I know if Tina's still around, she had a warm-up question. I'm getting there. There it is. Okay. It's in your notes too. There's a little chart in your notes. I don't know what on page, but there you go, Denise. Yeah, I'm going to do the warm up here in just a second. Okay, Marilyn, I had a couple questions. Tina, I know had a question. Do you want the first one or the second one or both, Marilyn? Because Tina just wanted the second one. 2? Okay, so let's look at 2. I gotta dig it up, so give me just a minute to get there. Not that button. Warm-ups. Week 11, Thursday. Okay, slope of the tangent line. So we needed to take the derivative using the quotient rule. Okay, do you remember doing the quotient rule the last couple of days? I hope. Let me get cubed 4x plus 2, and then we have to plug a 1 into it. Okay, so let me get to somewhere where I can write that out. Okay. So we had our function is f of x equals x cubed over 4x plus 2. So I need to use the quotient rule, which means my numerator is my red, my denominator is my green. And I'm going to take the derivative. So the derivative of my red is 3x. I keep my green the way it is, 4x plus 2. I'm going to subtract, okay, because that's what the formula says. I keep my red the way it is, x cubed. Take the derivative of my green, which is 4. And then I'm all over the denominator, or the green, squared. I would not simplify it. Yes, it'd be squared, thank you. It wouldn't change my final answer in this case because of what I'm plugging in. So in this case, I would not simplify my algebra because it's a lot easier to just plug in your x value. So I'm going to plug in my x value. So f prime of 1 equals, because it was a slope at x equals 1. So I'd have 3 times 1, which is 3. 4 times 1, which is 4, plus 2 is 6, minus 1 cubed is 1 times 4, all over, this would be 6 squared, right? Because it'd be 4, yeah, 6 squared. So I have 18 minus 4 over 36. 18 minus 4 is 14 over 36, which equals 7 over, is it 18? Are we doing okay now, ladies? I know a couple of us are hanging out looking. Is it making sense now? Where am I losing you, Marilyn? Okay, I'm glad it makes sense, Tina. Okay, I'm glad you're okay. All right, yeah, I was kind of quick, sorry. You're welcome. All right, if there's no other questions, I will see you all on Monday.